Math 1108, Section 9.3, the Quadratic Formula, Part 2. We're using the quadratic formula to solve equations, so I'll just rewrite the quadratic formula here. X equals negative b plus and minus the square root of b to the second minus 4 times a times c, all divided by 2 times a. In this equation, 3x squared minus x plus 2 equals 0. The value of a is 3. B is negative 1. And c is positive 2. So we apply the quadratic formula. We write x equals the negative of negative 1 plus and minus the square root of the number negative 1 squared minus 4 times 3 times 2, all divided by 2 times 3. Then we do arithmetic. The negative of negative 1 is 1, plus and minus the square root of some number, all divided by 2 times 3, which is 6. So inside the square root, the number negative 1 squared is positive 1, and we're subtracting 4 times 3 times 2. We're subtracting 24. So 1 minus 24 is negative 23. Well, we know that the square root of negative 23 is not a real number, but we also know how to simplify square roots of negative numbers. So we'll do that in the next part. X equals 1 plus and minus. Remember how to think of the square root of negative 23, I mean. Think of that as the square root of negative 1 times the square root of 23, all divided by 6. And then we replace the square root of negative 1 with I. So our solutions are 1 plus and minus I times the square root of 23, all divided by 6. So the two solutions are non-real. The discriminant is negative, so of course they're non-real. Okay, we'll do 3 more examples. Okay, on this one, the directions say use the discriminant b to the second minus 4ac to classify the solutions to the quadratic equations, and then find the solutions. Okay, so first we're going to find the discriminant. The discriminant is b to the second minus 4ac. For this quadratic equation, the discriminant, well, let's identify a, b, and c first. A is 8. B is the coefficient of y, so b is negative 9. And c is positive 9. And so the discriminant, b to the second minus 4ac, is negative 9 squared minus 4 times 8 times 9. And then we just do the arithmetic. B to the second minus 4ac. The number negative 9 squared is 81. And we're subtracting 32 times 9. So let's see, that's just 288. And 81 minus 288 is negative 281. Okay, so the discriminant is negative. And remember what that means. That means the equation has 2 distinct or 2 different non-real solutions. So I'll write that over here. The solutions are two different non-real numbers, or two distinct non-real numbers. Either way is okay. The solutions are two different non-real solutions. Well, we can write down the solutions. We already did some of the hard work by finding the discriminant. So y is equal to the negative of negative 9, which is just positive 9, plus and minus the square root of the discriminant. The discriminant is negative 281. And then this is all divided by 2 times 8. So we'll take it one step further. The square root of negative 281, that's the square root of negative 1 times the square root of 281. And then the square root of negative 1, we write I in its place. So we can write the solutions as 9 plus and minus I times the square root of 281, all divided by 16. Okay, the square root of 281, that can't be simplified any further than it already is. So those are the two solutions, non-real solutions. Okay, the next example, this time the quadratic equation is in the variable m. M to the second minus 9m plus 3 is 0. Okay, so we'll identify a, b, and c. A is 1. That's the coefficient of m squared. B is negative 9, and c is 3. Okay, so the discriminant, b to the second minus 4ac, is the number negative 9 squared. That's b squared. And then minus 4 times 1 times 3. So we'll simplify a little more. B to the second minus 4ac. The number negative 9 squared is 81. And then minus 4 times 1 times 3 is minus 12. And that simplifies to 69. Okay, so since the discriminant is a positive real number, this solution has two different real solutions. So the solutions are two different real solutions because the square root of 69 is a real number. Okay, we already did all of the hard work by finding the discriminant, so we can write down the solutions. The solutions for m are m equals the negative of negative 9, which is 9, plus and minus the square root of 69, all divided by 2 times 1, which is just 2. The square root of 69 cannot be simplified any further. If you want to write the solutions separately, you can. One solution is m equals 9 minus the square root of 69, all divided by 2. The other solution is m equals 9 plus the square root of 69, all divided by 2. Okay, one more example. 81a to the second minus 90a plus 25 equals 0. This is a quadratic equation in the variable a. So in this one, lowercase a, not to be confused with capital A, lowercase a is 81, b is negative 90, and c is 25. Okay, so these numbers are bigger. We might need more room for the discriminant. So b to the second minus 4ac is the number negative 90 to the second minus 4 times 81 times 25. So we'll simplify that a little bit. B to the second minus 4ac. The number negative 90 squared is just 8100. And notice here, 4 times 81 times 25. If you multiply 4 times 25 first, that's 100. Whoops, this is supposed to be minus. Sorry. 4 times 25 is 100. 100 times 81 is 8100. So 8100 minus 8100 is 0. The discriminant is 0. So remember what that means. If the discriminant is 0, then there is just one solution, but we say that it's repeated. Okay, so there is one repeated real solution to this equation. So we can find the one repeated solution using the quadratic formula. So m equals the negative of negative 90, which is 90, plus and minus the square root of 0 divided by 2 times 81, which is just 162. But the square root of 0 is 0, so there's just one solution. And we can write this in lower terms. 18 divides into both 90 and 162. So I'll just write 90 over 162. 90 is 5 times 18, and 162 is 9 times 18, and then 18 divided by 18 cancels, so the one solution is 5/9. Well, I'll show you just one more thing since there's time. If the discriminant from a quadratic equation is ever 0, it means that the trinomial is either a perfect square trinomial or a constant multiple of a perfect square trinomial. Since the greatest common factor of all three terms is 1, then this is a perfect square trinomial. So remember how to factor a perfect square trinomial. Whenever you factor a perfect square trinomial, the binomial factors are exactly the same. So factoring that is 9a minus 5 times 9a minus 5. And then if you solve this equation for a, since both of the factors are identical, you can just use one of the factors. 9a minus 5 is 0. Add 5 to both sides. 9a equals 5. And then a equals 5/9. Okay, I see what I did wrong. For some reason, I used the wrong variable up here. This should be a, this should be a, and this should be a. But I think we're all okay now. So there's only one solution. A equals 5/9.